Uh, Thanks a lot, uh, first of all, for willing to take up this workshop and get into this training on a Friday afternoon. I'll try my best to keep it as interactive and as interesting and fun as possible so that it's worth everyone's time. So, without wasting much time, let me just take a minute to give a high level perspective of what this workshop is all about and what is the goal or the objective or the value that I'm planning to deliver. And if this is in sync or aligned, or if it interests you, great. If not, maybe if you could let me know, we can use the chat window, or you can even use the mic and talk to me. Tell me if your expectation is something else apart from what would be delivered, then definitely I'll try my best to bridge the gap and meet the expectations. So the workshop that was planned was 3 to 4 weeks workshop. This first one is going to be an introduction to TRIZ, and I'll also be talking about what we will be doing in the consecutive workshops, how the entire workshop is going to be structured. The objective or the goal that I had for myself was that every participant who comes into this workshop, when this workshop ends, that is by the end of the last week, when the workshop ends, they should be having either, number one or more white papers that can be published in a reputed journal. Number two, it could be an idea that is worth patenting and can be executed, an entrepreneurial opportunity, number three, or fourth, a book that can be published eventually. And if you ask me, are these possible in the next 4 or 5 hours that we would be spending over a period of time? Definitely yes, it's possible. That's the power of TRIZ. So without wasting much time, let me quickly move on into the topic. Before I even talk about TRIZ, innovation, etc., the most basic fundamental of innovation, or I would even call the enemy of some of the biggest innovators, is something called as a psychological inertia. Here is a quick activity for you all. Please grab a pen or pencil in your hand. And you have exactly 5 seconds. I'll be counting 1 to 5. Is everyone ready? I can't see the chat here. Okay, so I'm just going to assume everyone is ready. You have 5 seconds. Can you quickly draw a flower? 1, 2, 3, 4, 5. So here's my question. Stop. The flower that you drew, is it something like, I'm sorry, this? Oh, I'm sorry, I said flower. I'm really sorry. Maybe it's the accent or it's the mic. Okay, so anyways, the essence is what is a psychological inertia? Our past experiences dictate the future of our thoughts, our imagination, the way we perceive things. So right from the kindergarten, this is the most basic way of drawing a flower that we have ever been taught. And that is exactly what we see here now. Now, the question is, at least in my entire life, I have never seen any flower which is even looks very similar or close to this one. So this is a psychological inertia. And the first basic step of any innovation is to break this psychological inertia. That is, to break all the past experiences that we have had and see the future or the problem through a very clear lens. And this is exactly what TRIZ helps us to do. So the principles of TRIZ and some of the fundamentals and the theories underlying within the pyramid of TRIZ will help us break the psychological inertia. How does it do that? It does it through a set or a series of processes and principles which we will eventually cover through this workshop. And henceforth, as and when we start solving more and more problems using TRIZ, the psychological inertia shouldn't be a problem at all for any innovator. The second most important thing I'm extremely sorry for the dog being. Just give me a moment. Sorry. The second most important thing to resolve or solve problems is the attitude of the innovator. There are two things. When we talk about Lean Six Sigma, what we are talking about is the stability of the process and how we take the process from ground zero, eventually upwards to meet whatever goal that we need to meet without disturbing the process in itself. Which means we are talking about stability, which means we are talking about measured risk. On the other hand, we have complete disruptive innovation, which is all about the risk-taking attitude, aggressiveness, etc. Let me give you a very simple example here. Does anyone recognize this man? Sorry. Okay, so he was the first man, he's called as the Flying Tyler. In France, what he tried to invent was a parachute that can be worn as a suit, and he tried to fly from the Eiffel Tower. Unfortunately, it was a disaster, and he passed away. And there was a half a meter hole that was created under the Eiffel Tower when he tried this experiment on himself. So this is about innovation. He's a crazy innovator with extreme risk-taking abilities. Now, let's just imagine, recently I flew from Germany to India and he was the pilot. Would you think I would board a flight if this pilot had this attitude? Definitely no. The answer is impossible. Why would I even do that? Right? So what we need to understand on any innovation process is that two things: the way the stable operation runs and the process of disruptive innovation requires two different set of attitudes. Extreme risk-taking ability to measured risk that is being taken to make sure the process is stable. Whereas in case of an extreme disruptive process, process stability is not a concern. We try to break the existing or the status quo of the existing process and take it to the next levels. Any questions so far? Clear. Okay, great. Now, how TRIZ works. Let me have a very quick activity and I need 100% participation. Feel free to talk or use the chat window, etc. Here is the thing. Find the fastest way the rat would take to reach the cheese. Okay, it's C. Any other answers? It's C. Okay. Wonderful. So the majority is C, so I'm going to go with C. Now, how did we, what is the fastest way to come at the solution for this kind of a problem? So many of them have answered C, which is right. So can anyone tell me how did you do that? It was pretty fast, very impressive. Exactly, backtrack from the cheese. Begin with the end in the mind. Fantastic. So this is exactly how TRIZ works. So there are two ways of problem solving, or I'd say two basic ways of problem solving. One is moving from the problem using different trial and error methods and arrive at the solution. The second one is start with the available solutions and then try to backtrack it to the problem that we have. So this is the most fundamental way how TRIZ works. So what is the advantage of this process? The problem with trial and error method is we don't have a complete confidence that we are going to arrive at a solution, number one. Number two, we burn a lot of resources, time, effort, and money. And there are many more that if I want to say, but I'm just naming the few. So this is the biggest problem with a trial and error method. Whereas the other method is guaranteed. How do I say it is guaranteed lies in how TRIZ was born. So in the slide, the picture that you see on the left is Hendrik Ursula. He's called the father of TRIZ, the inventor of TRIZ. I'll just take a few minutes to explain the story on how TRIZ was born. Like Einstein, Hendrik Ursula was a clerk in one of the patent office, and his job was very simple. Every single patent in Soviet Union used to come to his table, and his job was to stamp and review those patents. He was so bored with his job, he started questioning himself how people innovate. Question number one. Are innovators born or they made? So how can a common man be an innovator? To solve this problem or to find an answer for this question, he started digging into every single patent that went through his table. And over a period of 15 years, he and his team had gone through 100,000 patents. And what they found out was there are just 40 basic principles that are used to solve a problem. And over in this course, over the next 4 or 5 hours that we are going to be, couple of hours we are going to be spending together in the next couple of weeks, I will be discussing these principles in detail. So these 40 principles can solve close to 95% of the innovations that we see so far in our day-to-day lives. And how are these principles formed? Purely on an empirical basis. So when I say empirical, this is through the observation that has been done over 100,000 patents. So these 100,000 patents were further broken down into some of the engineering parameters, like what problem are these patents trying to solve? What is the principle that was used to solve this problem? And the basic underlying theory came into picture, which is if I can understand a particular problem in a patent and the principle that is used to solve that problem, that could be a similar problem in future, which has similar parameters that needs to be solved. So all I will do using TRIZ is use the same principle, see how a particular similar problem was solved in the past, and I've used the same principle to solve the problem in the future. Very simple. In short, it is like training an AI, artificial intelligence system, any kind of AI. So what do we do with an AI? We train the AI on the principles or the parameters that we need to use to solve a particular problem. The AI will start learning the basic algorithm or the structure. And as and when we proceed, the AI knows for these two set of variables, what should be my outcome, or what should be my most probable outcome. So this is a good point, I think, to talk about it. So me and few of my colleagues using TRIZ, we have been building a chatbot, which you will be seeing in this course. And if possible, you will also be using I'm extremely sorry for the, you will also be using the beta version of the tool where you'll be chatting. So how this tool works, or this chatbot works, is you'll be chatting with an artificial intelligence which has all the intelligence of TRIZ, and it will help you innovate. So through this, when I say help you innovate, you can bring the product and start talking about that product with a bot, interactive bot. And this bot will start using the principles of TRIZ. It will ask you, okay, what is the CTQ that you want to improve in this particular product? How can we improve that? What are the principles that can be used? And it will get deeper and deeper. It's like literally working with a virtual consultant. So, okay, back to TRIZ. When Alstiller was working on TRIZ, the question that might come out is, okay, if TRIZ can solve close to 95% of the problems, then why is it not as popular as Lean or Six Sigma? One of the fundamental problem is, I'm sure most of you would recognize the person on the right-hand side of the slide, which is Stalin. So the entire process of TRIZ and the evolution of TRIZ took place during the Soviet Union time. So when Soviet Union was in power, everything remained in Russia till the Soviet Union broke in 1992. And later, eventually, TRIZ started slowly becoming popular in US and Europe. And now most Samsung uses TRIZ extensively, Accenture uses, Microsoft uses TRIZ extensively, just to name a few, for all kinds of new product designs and evolution. I'm just going to stop here for a minute and just ask if there are any questions. And you can feel free to talk. Okay, no questions. So I'll go to the next slide, which is the TRIZ magic. How does TRIZ work? The magic of TRIZ. So let me start with a very basic fundamental, that is, any kind of innovation starts with the problem, right? So the beauty of TRIZ, Alstiller, and every single individual who have been working on TRIZ is the way they defined a problem. Does anyone want to take a shot and tell me what a problem is in your perspective? Simple English. Oh, okay, no problem. So problem is nothing but a set of contradiction. So what I mean by a contradiction is, I want to improve something, and when I try to improve that, something else which I do not need, which is undesirable, happens. So in short, it's like I want to improve X, and when I try to improve this X, Y happens, which is something I do not intend to improve. If I want to give you a very popular example in the field of TRIZ, is let's take an example of a policeman's bulletproof vest. A bulletproof vest has to be strong so that it can take the momentum of a bullet. But for a strong vest, it has to be heavy. Now, a heavy, strong vest is good to take the hit of a bullet, momentum of the bullet, and make sure the policeman doesn't get hurt. But if the bulletproof vest is heavy, it's going to make it hard for the policeman to run, right? Here is a contradiction. I want to improve the strength of the bulletproof vest, but at the same time, what is undesired is I don't want to increase the weight of the vest. We have a contradiction here. And this is one example of a contradiction where we have the parameter that I spoke about now are two. One is the weight of the vest, which is one parameter. The second one is the strength of the waist. So these are the two parameters that is forming a contradiction for me here. So in the overall TRIZ contradiction, it's a classical TRIZ contradiction matrix. We have close to 39 parameters. You have weight, you have area of the object, you have the energy used by the object, etc., which we will be seeing eventually over this course. Now, how do I resolve this contradiction? Using the 40 TRIZ principles. I'm sorry, I think that's something. Okay. Using the 40 TRIZ principles, I can solve this particular contradiction. So how TRIZ would work in this case is, it will go and check, okay, what are all the problems or the patents that came on the desk of generic Astilla, which had a similar contradiction where they had to improve the strength and reduce the weight. It could be a problem that might have happened in a spacecraft or a ship or an automobile, anywhere. How did they solve this problem? There could be 2 or 3 principles that they might have used. And using these principles, I can resolve the problem and innovation is born. You have the first innovation. Now, any questions so far? Okay, none here. Okay, sure. So this is one part. So this is exactly what we are going to be doing over the next couple of weeks. Is you will be bringing a problem into this course or a product, anything. It could be a business problem, or it could be something related to engineering, manufacturing, etc. And for these problems, we will be identifying the contradictions and we will be resolving them, and we are just going to keep on innovating and improving the product that you bring into the course. Now comes a very important question that you would have come across. Every time when we try to solve some problem, the most basic fundamental is, what is the problem? We don't have a problem. How do we identify a problem? So in case of Lean, Six Sigma, or any kind of process improvement, we have different standards, right? We have benchmarking. We had the what is the customer baseline or the target? What is the competitor benchmark? What is the market benchmark? What is a process benchmark where internally, which my industry standard is being, what are the best in class benchmarks that we have? So these could be a good metric to identify a problem in case of, especially a Six Sigma problem, if you want to try to solve, or the voice of the customer. But the beauty of TRIZ is it has altogether a different way of defining a problem. So let me introduce you to the concept of ideality. What is ideality? TRIZ says that every product has its ideal state. Irrespective of you improve it or your competitor improves it, it doesn't matter. Every single product moves towards its ideal state, or what we call as an ideality. What is an ideal product? According to the principle of ideality in TRIZ is, an ideal product has maximum benefits with literally zero or less cost and harm. So this formula that you see here, just you can take it with a pinch of salt. It can't be used for any significant calculations. It's just for representations. I'll also tell you eventually, maybe in the end of the session, why it can be used for reporting or calculation purposes. But yes, on a whole, an ideal product is something that has all the benefits that you need and no cost and no harm. You can pick any product that you want, and you would see that. Just ask yourself, what was this product 10 years back, 20 years back, 30 or 40 years back, and just see what it is now. Let me just take the simple example of my cell phone that I have here. Graham Bell invented this phone, and maybe what was the harm? It had a lot of noise. Second thing, it was connected. It was not dynamic, which means it was not mobile. I couldn't carry it anywhere. It was fixed because it was wired connection. Then eventually what happened? Then we got, and it was very expensive as well. Then eventually, before the mobile phones came, the price of the landline phone started falling slowly. And then came the era of the mobile phones. Then we had a lot of problems with that as well. Like, it was large. Again, it had the problem with noise. It was expensive. I still remember the days when a per call charge was close to $2 or $3. Then imagine what happened 10 years back. The size of the phone started declining. The call prices became really, really, really cheap. And it almost reached an ideal state, which means it had all the benefits of a simple phone. That is, communicate without any noise or gap in the information that is being shared. Great. The harm was almost nullified, except that yes, there are a few radiation impacts on the human bodies and the bees in the environment, but it will be taken care of soon through, as per the principle of ideality. And then thirdly, the cost has come down. So it reached a point of ideality. Then there is the unwritten rule of our TRIZ. That is, once a product reaches an almost ideal state, what happens to that product is it goes and combines with the super system of another product, which means that there is some other product in the environment. This would go and become part of it, which means that there is a laptop. The phone becomes part of it, starts performing the functionalities of other objects, other products around it. It could be the laptop because you can check your mails, you can check emails, etc. And you can take pictures, camera, etc. So other products will start get combining. There are a lot of theories and laws of TRIZ, but ultimately it is not in scope of this particular course. But what you need to know at this moment is the concept of ideality. The reason why it's important is when you come next week, you have to come with a problem or product with an end goal that by the end of the third week, you will be having a white paper, or I said an improvement idea or an innovation, or the third thing is it could be a book that's going to be published related to the problem that you bring into this workshop. So, and so for you to bring a problem or a product, you need to have a method to identify the problem. Just go and ask yourself, what are the benefits that I have in my product or a problem? And what are the harm that is affecting my customer or my employees or the suppliers, any stakeholder who is involved in that particular business problem or a product? And how much does it cost now? If you bring these three problems, then you have a problem right away to minimize the harm and cost and to maximize the benefit, right? And once this is done, we can start with the innovation process. Any questions so far? Okay, so let me move to the next slide. Now you can ask me another question. Fine, Sunil, you're telling me that TRIZ is able to solve these many problems using few principles. What exactly are these principles? How does the magic of TRIZ work? It uses a very simple logic, or I would say a methodology or science. What TRIZ does is it separates a problem in space and time, which means that it will ask you questions like, when is this problem happening? Before a particular process or after a particular process? In which space is this problem happening? At a component level, or at a process or a system level, or at a super system level? And all the 40 principles, the way they work is, let's say the red dot that you see here is my problem. And the way to read this or see this slide is, we call this as the 9 windows. I have the past, present, and the future on a x-axis, which is time, past, present, and future. And in space, I have my subsystem, which is nothing but the components of my product or tools, etc. I have my system, which is the end product, and I have my super system, which is the environment surrounding my object, or where my object interacts with. For example, if I take the cell phone and if I put it here in my 9 windows, so the subsystem is all the components, the chips inside, the battery, etc., are all part of the subsystem. And the super system is the signal, the cell phone signal that I get, the climate, because it can affect my cell phone, and where I place my phone, the charger, because it is not part of my system. Because charger, anything and everything that interacts with my cell phone is a super system. Now, what is the past? I can define the past in whichever time scale that I want to. I can say that, okay, before I got this cell phone as an end product, it was in a state of assembly, which means it was in a box with all the logo, etc. And here the components would be the box, the plastic cover, the warranty that I received with it. And the super system will be the store where I went and bought this, maybe the Apple store here, etc. And what is the future? Eventually, once the phone dies or something, I'm going to say that here, let's say I'm targeting the electronic waste, which means that here it's going to be a cell phone that is not functioning anymore. And here my subsystem will have dead batteries. Sorry. Fantastic question, Blake. I'll just hold on to it. I'll definitely answer your question. So how can my particular cell phone uh, the electronic waste, etc. And super system will have all the impacts to the environment that is affecting my the environment, how the environment is getting affected through this electronic waste. So this is what exactly how a nine window works, and how the principle, what the principle of TRIZ does is it will try to solve a problem. For example, there is one principle called as prior action, which means if you are performing a particular action here, can it be performed before that? Or there is another principle, for example, called merging, which is can you bring something else, some other object, which is in future or in the past or in the subsystem or supersystem together, right? So there are different, this is exactly how the principles of TRIZ work. You either separate the problem in space and time. Another principle is segmentation, which means that break the object into different segments and put them in different space or time. For example, this principle was a breakthrough for the DSLR or the camera industry. 20 years back, or I would say, I'm sorry, 25 years back, we had cameras with fantastic lenses, but the problem was every time the customer had to go for the next generation of camera or advanced version, he had to throw off the entire camera and buy a new camera, just because the lens is not detachable. So what the principle of TRIZ would say in this kind of a parameter is very simple. Segmentation, which means separate it, segment the camera and the lens and start selling it as two different products. So that's how this works. And coming back to the question from one of the participants here, fantastic questions. These are good for physical problems, but how can I use it for transactional problems? Super. Now, this brings to a very interesting topic. I will just spend 2 minutes here. The problem with TRIZ till 2000, or even now, till 2015, I would say, is TRIZ was created by engineers for engineers. That's how TRIZ evolved. It evolved through the engineers. It was not a businessman or a business consultant or a chartered accountant who worked on TRIZ. It was all engineers, and they tried to solve the engineering problems. And eventually, some of the researchers started thinking, how can we use, because until the last, before 20 years or so, business process management was not big, as big as an engineering problem. Business process design was not a big problem because the business processes were not as complex and as global as we see it now. Now, to answer the question of Blake, how can we use TRIZ for problems, business problems, which is transactional? Very simple. So, and this is exactly what my book is all about as well. So I've translated all the engineering problems into business problems, and the entire contradiction matrix, which I'll be showing soon, has been translated for business problems. But I'll just give you an example. Energy used by the object is one of the parameters, engineering parameters. The equivalent of that in a business problem is the money spent or the budget spent or consumed by a resource or by an activity. So a business problem can be pictorially, as a metaphor, represented in form of a physical problem, which means we are just converting a business problem to a physical problem. Use the contradiction matrix, see what are the principles used, apply those principles, resolve, and the business principle is resolved. Let me quickly jump on to the contradiction matrix, and I'll show you a practical example here. So I don't want to scare you, but this is how the contradiction matrix would look, which is very scary. So you have all the parameters that you want to improve and the parameters that is stopping you from improving. And for each of these combinations, you have the set of principles. but I'll just keep it simple here. I can choose whatever parameter that I want to improve. These are the 39 parameters that we have. The weight of the object, the length of the object, area, or volume, speed, force, pressure, etc. Can you see the parameters now, please? The loss of information, etc. So these are the, as you can see here, we have 39 parameters. And so, for example, now automation is the biggest mantra, right? Level of automation, you have it. I want to automate as many processes as I can, business processes as I can. Fine. So now let me take and then the same 39 parameters are repeated here, but that is what is stopping you from improving. Fine. So it could be is it weight, length, etc. Let me take a very simple example, that is this is one of my favorite examples. So I have a water bottle here, which I take every day to work or when I'm cycling. Now, my problem is, this is a 1 liter water bottle, which means the volume of this bottle can hold 1 liter of water. Let's say I want this bottle to hold 5 liters of water. But if I try to do that, the area of the bottle increases, which means it becomes bigger and it becomes really hard for me to carry. Right? So this is the contradiction. Now I want the bottle to be small, but I want the amount of water that it can hold to be more. So I have a physical contradiction here. Now, if I go back to the 9 windows, so what I have the problem here, that is, so this is exactly where, and what this point is where I face the problem, this red dot. And what is the point? It is when I'm drinking the water. Fine. I'm drinking the water. In the past system, I'm carrying the bottle with water, and in this, I've emptied the bottle. It's an empty bottle, let's say, or I'm saving it. Now, what TRIZ is gonna do is, let's go back to the contradiction matrix. Just a moment. I'm sorry, does anyone have any questions? I can't see the chat. Okay. Now, I will choose area of volume of the moving object. I call it as a moving object because it's going to be moving with me. It's not static at one place. And here I have the area of the moving object. Now, once I select these 2 parameters, I have these 4 principles that can be used to solve this problem. Number 1 is segmentation. What segmentation says is, break the bottle into different parts. Segment it. And how will this solve the problem? Is, okay, when you want to drink a lot of water, I'm sorry, does anyone have any questions?
Yeah, Sunil, this is Muthu. Can't see the parameters, and like Blake was asking if you're using a second monitor or something. Like we can't see the parameters. I don't know if you have it in a separate window.
Oh no, okay. Oh really? Oh, I'm sharing my screen. Oh, okay. Because I think I'm sorry, because in this tool, I'm extremely sorry. Because I was in this tool, I selected share the presentation. I need to, I think, go and separately. Okay. Oh, I'm sorry. I think I know why it's happening. Okay, I'm sharing my screen. Okay. Now I'm sure you should be able to see my screen.
Yes, we can. Yeah.
Okay, because I'm sorry, instead of sharing the entire screen, I was sharing my presentation. So I think every time I move out, it was blank. Fine, so I'm sorry, I'll just go back. So this is the contradiction matrix. It looks like these are the parameters I want to improve. These are the parameters that stops me from improving. And for each of these combinations, I have set of parameters. You don't have to worry about it. It's in a much more simplified format. So, and I was saying these are the 39 parameters: the weight of the object, the length, area, volume, etc. And then I have the same 39 parameters. Like for example, level of automation. If you want to improve productivity, or if it impacts your productivity, adaptability, repairability, there are a lot. So we will be seeing these parameters throughout this workshop in the next week when we meet. Now, so going back to the problem, so when I choose the volume of the moving object and area of the moving object, I get these 4 principles here. So the first principle, as I was saying, is segmentation. So what it says is break the bottle into numerous segments and have more and more segments. Whenever you're drinking, whenever you need 5 liters of water, add those segments, which increases the area at that particular point of time, and then just remove it whenever you don't need it. So which means that I'm separating the problem in space, in time. I'm sorry, not in space. Right? So as and when I need, I'm going to carry a small cubes, which increases the size of my bottle. That is what segmentation is all about. Next, the second principle is called nesting. Nesting is nothing but putting one inside the other, how a telescope works, or the Russian doll. That's where the nesting comes from, the nesting doll. So what it says is put one bottle inside the other, and as and when you need more water, fill it up, and as and when it's getting over, fill it back in. So this is one way of solving the problem. Asymmetry. So this is a beautiful concept. As if I want to ask you, what are the symmetrical parts in this bottle? As you can see, these two are symmetrical, and even these two sides are symmetrical. What I can do is, if I make it asymmetrical, like a zigzag, on both the sides, whichever is symmetrical, make it asymmetrical. That's what the principle of asymmetry means. What will happen is this bottle will be kind of collapsible, which means I can make it smaller or larger. It grows, the size grows as and when it needs to improve. So this is the principle of asymmetry. And then the last one is moved to another dimension, which means that it's like a Swiss knife. Okay, now the bottle is more towards the x-axis. Can you make it move towards y, z, like a Swiss knife, how you can expand and collapse it through different dimensions? In short, these are the only 4 ways in which I can solve this particular contradiction or a problem. Any questions? Now there are 2 questions here. Screen is only displaying PPT. Okay, got it. Okay, great. Fine. Now let's take a business example. I want to automate all my processes, which is nothing but the level of automation. I want to automate as many business processes as I can. But what happens when I try to do this is, as I said earlier, the energy can be used as the money. I don't have the budget to automate all the processes. Fine. And these are the principles that can be used for this. One is, see the beauty of TRIZ, separation or extraction, which means that remove all the non-value added activities or the process steps. It could mean 2 things. Remove all the non-value added activities in the process of automation itself. Like let's say that to automate a small process step, I need to prepare a 20-page documentation. TRIZ says, no, don't waste your time and energy on that. Remove that process step. Second thing, even before automating a process step, see if that process step can be removed completely, which is the principle of lean, right? So this brings me to the next topic. Lean and Six Sigma is a subset of TRIZ. Many principles that is used in Lean and Six Sigma, no, I'm sorry, all the principles that are under Lean and Six Sigma, directly or indirectly, is part of TRIZ, is a subset of TRIZ. So this is separation or extraction. Second one is the most beautiful, innovation, optical changes. So what do we mean by optical changes is change the way something is being seen. Like for example, change the color, change the lighting, change the format, change the text, etc. So optical changes, what it can do is, for example, let's say that if instead of having a text that has to be read by an OCR, an automation software that has to read the text from the screen, it has to extract it, can you simply color code it? Red, green, amber. If it is red, I know the context. I don't even need to automate anything. If it is red, I'm going to say high risk. If it is green, I'm going to say it's good. So this is one. And the third principle is it's the other way around. That is, do the exact opposite of what you're doing. As my problem is not very specifically defined here, I wouldn't be able to explain that very clearly, but this is what it means. Do the exact opposite of what you're doing. So this is the beauty of TRIZ. Any questions? Okay, great. So we have the last 5 minutes now. So I'll quickly go to the, sorry. So what we would be doing in the, I'm just gonna, this is my last slide. What we are gonna be doing in the next couple of weeks is, we have a problem. You'll be coming up with a problem. It can be any problem. It can be physical, engineering, business process, etc. It can be related to arts as well. We take the problem and we will be seeing which component of the subsystem, which is which component of that particular process or product is stopping. We will identify the contradiction here. We will try to resolve it. If not, we see, is there anything in the super system that is stopping? No. Then we go to the previous process and see if this previous process is stopping from improving this particular CTQ or parameter. No, then the component, then we keep on repeating, and every single arrow that you have here is an innovation or a new thought process. And the number of arrows here are the number of innovations that you will be coming up with, telling, doing this way, I will be able to improve this particular process or product, or I will not be able to improve this particular process or product. And by the time end of this workshop, we do all this, you have a huge list or bundle of case studies, or I would say success stories, failure stories, why something can't be improved, what kind of technology is stopping this particular product from improving, so that in future, when is this technology going to appear in this market, etc. So it's going to be a robust case study. And just to give a simple example, I've connected many workshops at different universities. It's just been a 3 or 4 hours workshop, and most of these workshops have delivered a white paper which is even published by some of the journals in ASQ as a success stories. One of the recent one is in Greece, where they came up with like how TRIZ can be used for digital marketing. So this is the plan for the next couple of weeks. Any questions, feedback, etc. I'm just waiting for you. And also let me know if am I too fast, etc. I know that there was not a lot of hands-on activity this week, but it will start from next week. Now you know the high-level concept.
Thank you, Sunil. Now, one thing I'm going to mention is like for the people who are attending this virtual workshop today, this is the first session. The starting next Friday, that's the session number 2, and then you have that's like a 2-hour session, and then the third session is also another 2 hours, and then the last one is another 2 hours. So a total of 7 hours over 4 weeks. Today is the first 1 hour, which is the introduction, and then you can sign up for the second, third, and the fourth. If you go to the Eventbrite link for this first one, you can sign up. There's a link for the second one. But what I'm also going to do is like send out the link as well as the recording of the webinar to all of you guys. So if you want to go back, you can do that.
Great, thanks, Muthu. And just last thing is, so over the last 2 years, I've, as Muthu rightly mentioned, I've cycled close to 21 countries where I was training people, trained a lot of developing countries on TRIZ and help them innovate, creating a lot of entrepreneurs through my journey. And I'll be doing the same the next year as well through Africa and America, creating innovators in these developing countries. So if anyone is interested, I do accept donations, but no pressure, as I mentioned.
Yeah, that's true. Like for the second, third, and the fourth, there's actually like doesn't say any cost to it. Like it's asking for donation, so it's up to you if you're attending. I think it seems like very interesting what Sunil was talking about, coming up with all these new innovations, but he's asking for donations, and from our section standpoint, whatever money we are collecting, we're going to give that to Sunil. We are not taking anything for our section. So he wants to do a lot of innovation, entrepreneurship, do that for people in the developing countries. So this is a great cause, and I hope you can sign up for the second, third, and the fourth sessions too. Yeah.
Thank you. And in the next session, I'll definitely try to come up with an innovation to see how to not make my dog bark.